Question 10 gives you a function, and the most interesting thing about it is that it has no numbers. It's only got a, b and x. So first you need to find f inverse x, which again, remember, is just making x the subject of the equation. This should become fairly routine to you by now. And you need to take note that x here cannot be equals to a over b, otherwise the entire denominator will not be will be 0, and so the entire inverse will not be defined. Okay. Hence or otherwise, find f square x. The question here is, what is this f square x that you are referring to? Now you have to know this, because f square x actually is just saying f x, which is f of x. It's just another composite function. It is not equal to fx whole thing squared. Please do not be mistaken. Okay, so fx would then just look like this. Not the nicest fraction. So you see, it actually equals to x, which is a rather simple composite function, and it's supposed to state the range of f squared. Now it seems like you can't really tell, right? Because there's a and b and whatnot. But if you think about it, for f of x to be equals to x, this is actually saying that f of x equals to f inverse of x. Do you see that? Because only if it were its own inverse, then you will be able, the composite function would be back to x. I'm not actually explaining this well now, but think about it, because only when I do the function, then I get back to x. In which case, if I do the function twice and I get x, then it has to be its own inverse. Think about it. It should make sense after a bit, despite my rather garbled explanation. Okay. So in that case, I would think that, okay, the domain of f here is actually the set of real numbers without a over b. The domain of f is also going to be the range of f inverse. I could then see f x as actually going to be f inverse f of x, in which case the range of ff is actually going to be the range of f inverse, which is going to be, oh sorry, I wrote something wrongly, going to be the range of f inverse f, which is going to be the range of f inverse, which is going to be the domain of f, which is going to be the same thing. The set of real numbers minus a over b, and that's all there is to it. Okay. For part 2, function g is defined by gx equals to 1 over x. For all real non-zero x, state whether the composite function fg exists, justifying your answer. So all they are asking is, remember, fg is the range of fg is the range of g, a subset of the domain of f. This is the question. Gx equals to 1 over x, and x here can be any real number. So just from here you can see that the range of g is going to be any real number, but it cannot be 0. For the demonstration purposes, if you look at the graph of 1 over x, the only y value which it does not take is y equals to 0, and that's because y equals to 0 is an asymptote. Okay? And we have the domain of g being the set of real numbers, the domain of f being the set of real numbers without a over b. Is this going to be a subset of this? The only way that it is going to be a subset is if a over b equals to 0. Now this, because that's the only way that the only way to fulfill both at the same time. So we look back at the question: can a over b be 0? The question actually defines f as a and b are non-zero constants, and if a and b are non-zero constants, then a and b can never be equals to 0, which means that the range of g is never going to be a subset of the domain of f. Therefore, fg does not exist, sad as it may be. Okay, and for the last bit asks you to solve for f inverse of x equals to x. What is f inverse of x? Remember from the earlier bit, f is its own inverse, so f inverse of x is actually the same as f of x. This is what they are asking you to solve, and you don't know what is f of x. Okay. F of x has been given to you: ax over bx minus a equals to x. So this is what you need to solve for. So you have two values, x equals to 0 or x equals to 2a over b.